si jamais. Est-ce que ça marche? Oui, bonjour. Bonjour à tous. Bonjour. J'espère que vous allez bien, que vous n'avez pas trop galéré à monter tous ces étages. Voilà, je vous accueille aujourd'hui. Alors, on va commencer en français quelques secondes. And we will switch in English. No worries. It's just to explain how it will go on. Okay? Donc, c'est un événement hybride, c'est-à-dire que vous êtes ici en physique, mais il y a aussi un live. Ne vous inquiétez pas, les caméras ne sont pas orientées vers vous. Il y a une caméra ici qui sont plutôt orientées vers les gens. Par contre, nous allons capter les questions-réponses. Donc, si vous n'avez pas de micro, les gens ne vous entendront pas. Ils ne vous verront pas, et en plus, s'ils ne vous entendent pas, c'est pas cool. Donc, du coup, quand vous avez des questions, n'hésitez pas à lever la main et on passera un micro pour que vous puissiez interagir avec, du coup, nos invités, our guests. Few words about Himaya. We are in a data consulting, okay? We are actually 25 people working with all kind of customer, from strategy to delivery. We want to helping crafting impactful AI products and data platform products. So we are actually nearly 2 years now. So we are quite a young company, and we want to share as maximum as possible, as you can see tonight. Okay. So tonight it's an international event, and Johan will introduce everybody. So I hope you will have a good evening. Thank you, Dominique.
All right, thank you. Good evening, everybody.
Good evening.
So just a few words about how it will work for tonight. So I have a screen here. If anybody has a question in the chat, I will have. So this is from this lunch, so it's in French. We had another event this lunch. Yeah, it's all right. But yeah, for everybody who has question, I will have access to them here, and it's like radio show format, so continuous discussion for about 1.5, and I will intersect it with 10 minutes talk from each one of you, and I will take questions from the public alongside the road. So just to begin, I have a beer here, but I can't. Sorry. To introduce the concept of this of tonight, so I thought I would start with Joe's data engineering life cycle, and why is that, and what is the connection with the three of you guys. So, no, sorry. Okay, so Joe is here, right in the middle. So on his, this is a schema from your book, Joe, and so you're basically the data engineering expert here, and so you sit right in the middle, but without, next slide, without Hala here, Joe does not a very great job because it just does pipelines, and but without, next slide, without Ole, to search the right data, I have access to the right data. It's also not possible. So tonight we have the three of you from end-to-end data in the AI lifecycle. So I thought it was cool to go back to your schema and put yourself on it.
I like it.
Yeah.
Thank you. It was a hard work to.
To steal our pictures.
Yeah, I worked a lot on
internet.
it. You will see the next slide for the conclusion. It's
Awesome.
Since you are really used to do a lot of interviews, podcasts, and so on, I thought you wouldn't present yourself, and you will present each other. Oh. So, Olo, I will let you present who is Hala. Hala will present who is Joe, and Joe will present who is Ole. Right? Go on, yeah.
So I begin? Okay. Well, thank you very much, Johan, for this beautiful introduction, and I'm very happy to introduce Hala Nilsson, that I came across when on LinkedIn, as I am sure everyone use every day. Hala is the author of Essential Math for AI, published by Reis, and I bought the book and read it. It's a great, great book. You're also a professor of mathematics at Madison University, right? Yeah, that's it. And as such a big authority in math. You have a background that is quite special. You came to the US, I guess, not as an adult, but relatively late in your life, right?
Yeah.
And so changed country. And I'm a big admirer of a very encyclopedic knowledge that you have on the topic of math.
Thank you. So I'm gonna introduce Joe. And Joe is, I tell him he is the godfather of data engineering, and he has the coolest shirts all the time.
Like this.
He impresses. He
You're kind of
impresses a lot
classic
of
tonight.
people. Yeah, I came. He is the author of the best-selling book in data engineering, Fundamentals of Data Engineering, co-author with Matt Housley, who's also an amazing guy. I came across Joe on LinkedIn while I was writing my own book, and I learned so much from Joe and his posts, and I connected with him, and then I got to know him, and he is wonderful in every sense of the word.
Thank you.
Yeah, and he travels the world, and I don't think he knows what time zone he's in at all, including today.
Actually, I literally don't. What time
Yeah.
zone are we?
Yeah, he
Is this
doesn't.
one?
Yeah.
This is
It's
He's
CET, is it?
plus
Yeah.
one.
Okay.
Yeah.
Yeah, exactly.
Yeah, but that one picture that Yuan put is from his book, and it is the one picture that helped me once and for all understand what data engineering is. I did AI before understanding. If you noticed, I'm at the very end of that picture, and it's Joe's picture that helped me understand what's before, and I always had a gap in that sense until I came across Joe and Matthew's book. So yeah, so there, and he's always sharing the knowledge with the world. He has a Substack that I support and you should support. So yeah, this is my introduction for you, Joe.
Well, thank you very much. Thanks. I'll Venmo you $10 later for
Yeah.
the kind intro. So yeah, Ole's a pretty cool dude. So he wrote a book.
That's it.
He wrote a book with a riveting title, Enterprise Data Catalog. I was like, this book just screams fun and excitement, and it just sounds like a giant party. So that's why I read it. I really wanted to read the book so I could learn how to be awesome like Ole. But in all seriousness, so he comes from like more of a kind of a library and information sciences background, right? Which I didn't know existed. So I come from a data and machine learning background in software engineering. So all the kind of the mainstream nerdy stuff. But then I realized there's people that are actually way nerdier, like Ole. But I've been learning a lot from your approach, your discipline's approach as well as your approach, right? I feel like it's one of the missing links to practitioners in data. Who's a practitioner in data? Who does data stuff or
I guess everybody.
everybody? I don't know why you would be here otherwise, but maybe because there's not even. Yeah, you have pizza at some point, right, or something. So some people I know they go to meetups for pizza and stuff, and I think that's how they actually have dinner. Is they just go to meetups, but Ole's. I think I've learned so much talking to people like yourself on the podcast and reading your book because you're on my podcast and I like to read the books of people that are on my podcast. But there's this whole other world out there, right? There's this whole other world. I think that we tend to approach things from a data-centric viewpoint, and there's really a knowledge-centric viewpoint as well that I think we miss out on a lot. And I feel like this is one of the big missing links that's going to make stuff like AI actually behave in a way that's useful, I guess. And so I think that books like what you write, what you wrote, and what you're working on, the ideas that you're espousing, I think are. It's interesting because if you look at what library science used to be, like I think if you had mentioned library science as something that you could check out, I would have stared at you very blankly and not known what you're asking me to do, and probably would have just walked off in the other direction.
A lot of people have done that to me. So.
I'm sure. Yeah.
Until you wrote this book.
Yeah. I mean, yeah. You're a lone wolf for a reason. So, but no, I've come to appreciate there's a whole other side to the world that I think we're just now coming to grips with, that people like Ole have been in for ages, right? So, yeah.
Thank you so much, Joe.
Of course, you're welcome. So.
All right, thank you for this. Enough of scratching our backs. And
Well, we introduced Jon as well.
Yeah.
you can try.
Okay.
I'll try just to moderate the conversation.
Okay.
All right. Before deep diving into your own books, the three of your books are all tech agnostic, and it's really like long living books. It's I think you all wrote it that way to survive long enough in this data field and not to be dependent on one particular technology or something like this. And I guess it all comes back to how to democratize data, AI, in a sense. And just I want just to start with one question for you, Ole. You started the podcast on data democracy, and you always begin by saying, so we explore what is data democracy is in your podcast. After, I don't know, 20 episodes, do you have a real answer of what data democracy is?
Not at all. Not at all. I do think, though, that a lot of people. So here's my. Oh, how much time do I have? I think
This is not your 10 minutes.
it's the 10 minutes.
No.
Okay. So I'll make brief here. I think data democratization means something different for Europeans than for people from the US, in the sense that data democratization is very linked to, I guess, big data and the idea of having Hadoop clusters in the US, whereas in Europe, at least that's my experience, data democracy has this societal connotation linked to GDPR and all the boring regulatory stuff, but also stuff that is really affecting our lives in a very serious way that we should take very serious. And I also think there's a difference in terms of new and old companies, in the sense that very new companies have very easy ways to make data discoverable and accessible and manageable, because they don't have a legacy IT landscape. They have very crisp cloud technology that is very easy to use for many end users. Whereas old companies, the majority of companies, they have a legacy IT landscape with an enormous amount of applications running, with no overview of the total amount of data and application. And in that context, if you blend difficult organizational politics, you get a very complex setup where data democracy is not something that is solved very easily. And I have been working in such environments for a very long time, and that is why I think data democratization is not an easy task. It's not a superficial term, and it's not something that we will see come into effect anytime soon in the majority of companies.
Same.
Can I ask you a question?
Yeah.
So, if data democratization is hard to define, can you provide any ideas of what data democratization is not?
Yeah, for sure. I mean, I think data democratization is not one technology. I don't think we can push data to societal extent where we have everything mimicking like governmental bodies, elections, and so forth. But we do have some obligations that mimic what we should do in what we try to do in democracies, in societal democracies, meaning have data governance where people take responsibility of usage of data and so forth. So like a one sentence like nailing data democracy, no, I don't think so. But I have that, but I definitely feel a very strong urge. I mean, I have been working I guess not all software vendors have actually known the industrial realities from the inside, but I have worked in very big, very complex industries, and not as well. I also had leading positions, but I also been in position where I was not at all the hotshot. Like, I had no authority in some of the positions that I've held. And I know that getting access to data and trying to actually work with data for the benefit of a company is not something that is easy. So that is really where I see data democratization playing a role.
Yeah, and I guess it's kind of the same with AI, right? I mean, in the hands of a few, and it's only if it's democratized enough that we have some balance and some checks for everybody.
Yeah, definitely. I think it's the hands of the few, and they're like, I think if people, there are a few who own the technology and who are distributing it to everybody, and at the same time, everybody wants AI. So all like the companies are investing in AI, but without the democracy, without like preparing their data and their infrastructures and exactly what you want to do with the AI, everybody has a different view on how to use it, rightfully so. Depends on what you do, what division you are in the company, what level you are, whether you have access to data or not. I mean, it's not like a one simple solution. And I think Ole like defines data democracy in a simple sentence like anyone has access to data they're authorized to at in any shape at any time. So that definition does resonate with people in companies at multiple levels. And I've worked with people at multiple levels, and I've tried to implement strategy, AI, data, etc. And yeah, so it's not a one. So the owners of these technologies and the producers of them and the ones who have the infrastructure that supports it, including the physical infrastructure like the data centers, the chips that train these models, or if you connect to them. So this is a huge topic, and yeah.
It's cool. So since you have the mic, Hala, for people who didn't read your book, shame on you.
Yes.
If you had to convince someone to read it in like 3 sentences, how would you?
Oh, my book.
Maybe 5.
I think it is a book that would demystify most of AI for you, and if it would connect so many dots together, you would never see AI as this big, confusing subject. It will demystify it. It will unify it. It's a unifying book, and I think if you want to start in AI and use it basically forever and be smarter in math too, then that is a book for you.
May I chip in here?
Yeah.
Because I actually read the book. And I think what makes your book so great, Hala, is the fact that many math books, including the ones I was forced to read in high school, are very pedantic repetitions of mathematical laws and theorems and proofs, right? What you do is that you flip-flop that reality entirely. And I don't read a lot of math books, like hardcore pure math books. So I don't know how many books are written in this style. But what you do is you flip-flop that totally and explain a lot of societal events, things that are happening in our society today, and then you reverse that reality into mathematical laws. And that is the coolest way to learn math that I have ever read. So that's
Thank
your
you.
book.
Yeah, no, that was by design. I believe I've taught thousands of students, and I've looked into their brain, and I realized that humans do not understand math the way it's presented, like formally, and it has to connect. It has to be driven by need and by use cases, and that's exactly how I drove math. And I think usually people get stuck in tiny details in math that are unnecessary, and these are people who end up creating entire fields that way that are useless. So I really try to undo that and change the whole philosophy and go back to how in the beginning math and physics and philosophy were all one subject, and that's how I present it in this book. And I think that AI in particular is a unifying subject in that sense. Like, because you have to think about reasoning and human. If you want machines to become intelligent, and then you have to rethink how AI is a unifying way to redo math, and I did that in the book. I collected math and I collected AI and I brought them together. Yeah.
That is very cool. One thing I like is I saw many books like just explaining what is a random forest or linear regression and so on, and so it doesn't help you think about what is under the hood and how to think about a problem. And I think it's one of your goals.
Yeah,
in your book.
exactly.
Are you going to write a book called Essential AI for Math?
I love that. I think I do. I actually, when I wanted the title of this book, it was kind of like that, and it's just who told me to do essential math for AI. I think of it as both ways. This book,
Yeah.
yeah.
So Joe, before being the godfather of data engineering in Hala's world, so you started in data science, right? I mean, you tell you're a recovering data scientist. What is
Yeah,
that?
that's true. I'm in recovery. Made a lot of mistakes in my life, so including being a data scientist. So, but you know, we all deserve second chances in life, and here we are today. So, just one day at a time. Yeah, but I'm actually giving a talk tomorrow, which is kind of funny because I think it's a bit clickbaity, but it's data science is dead. Long live data engineering. So
Oh, that's so cool.
we'll find out how cool it is. My passport bound in France after that. But yeah, it's interesting because there's the essential stuff. So it's interesting when you talk about data science too, because I feel like that's a if anyone knows what that is, like feel free to well, type it up there or say something. But it's a term that I think intentionally actually never had any meaning to begin with. It was sort of meant to like be used for HR department at LinkedIn and Facebook to get more applicants. So there's actually never been an official definition of it. But so it's interesting when I see data science curriculums is there's I think two schools of thought. One is that you before you do machine learning, you need to know a lot of math. Right, and I have a math background. You have a math background. You have a cooler math background than I do. But I studied math. I was on my way to being an actuary, which I guess was a cool job in 2000.
Yeah.
So, right. But then there's the other camp that says, oh, you don't need to know any math to do machine learning or AI, right? So.
Or you just do the models.
What's
I
that?
guess.
Yeah, but then you're just
They
plugging
want
and
you.
playing in like
Yeah.
function calls and stuff. So. Yeah, so it's interesting, but I'm always a fan of kind of going back to first principles with with those subjects, and I feel like, math it's core to, well, it's kind of core to machine learning and AI because that's how it literally works. So you should probably know that stuff. But I think that same approach influenced kind of how I wrote the Fundamentals of Data Engineering book as well, where it was very much a first principles book. I mean, the dirty secret is actually our original acquisitions editor at O'Reilly, Jess Haberman. She knows I talk crap on her all the time.
Yeah.
She told us actually not to write the book because it's like, why you and Matt are two first-time authors. Like, why do you think you can define an entire field from first principles in a way that's technology agnostic? I think it's a fair question, actually. And I was like, Matt and I are kind of dumb, and we don't really want to write the other book, which is data engineering on AWS or whatever. So. We decided to write that book, but I think it was very much geared towards, because Matt and I are very much first principles people as well. So I think that, and Matt's also a math professor, right? So I think that the math training helped us a lot when writing that book and kind of framing the approach to it. I don't think we would have come up with the ideas otherwise, at least the idea of approaching it from a technology agnostic angle. So, yeah.
And how does your book resonate like today in this area where you just throw data to every kind of machine learning model and just see what goes on? And it seems like today, more people don't even care about the maths behind the machine learning models, and even with LLMs today. So, does your book resonate to for a lot of people? And do you feel that the world needs to understand the maths behind the models right now? I guess I know the answer.
Can I ask an adjunct question too? Is linear regression machine learning?
It is machine learning.
It is? Okay.
Yeah, it's like the first one you learn. It's the first approximation of all the others.
Is addition?
Addition?
Yeah.
Oh, boy. Okay.
I'm just joking with you, okay.
Input, output. Yeah, the simplest ever. Yeah, it depends on what your application field is. I would say some people are like religious in the sense that you have to understand every single thing and every flaw in your model, and how certain you are about the outcomes, and why you're employing this model and not that model. I think all of this is fair, but it depends on the use case. Like if you're just playing around with, say, a large language model to generate a worksheet for your class, no one is gonna, go to the hospital. No one is gonna die if you use that, right? And how accurate your generation is. But if you're using your model to like prescribe the next medicine path you should put your patient on, then you have to be super careful. So, or if you're doing auditing, compliance, all that, then you have to be telling me how certain you are. You have to be quantifying these things, and you have to be telling me why you're using this model and not that model. And that's when you have to know the limitations of the tools that are under the hood. So it all depends on your use cases and who your clients are, if you're a consultant, and how much dependent they are on how like much difference it's gonna make if you change this input, if you change these variables in this input, and then the outcome changes, and based on that changed outcome, you have new decisions, and these decisions affect someone. So it all is context dependent, and if you're just playing around with it, it's different than if your whole business model is based on it. And we've consulted with people where these things mattered, and we've consulted with people where they didn't really care what. We just wanted a model that was better than what they were having, and that's it. So it all depends. And usually, if you're talking with the people who are running the business, what they care about usually is trust. They wouldn't ask you exactly why and how you're getting these numbers, but if they trust you as a person who's actually looking into these things, then that works as well. So yeah.
Can I ask you a question though? So it's something I've been thinking about with respect to the notion of overfitting.
Mm-hmm.
So I guess in whatever like non-generative AI or machine learning, right? There's a notion of overfitting where you're people familiar with the concept of overfitting in machine learning, right? So overfitting is generally bad in those cases because your model's gonna be too brittle. But what about the case of large language models where you probably want it to appear accurate? Where does overfitting play into that?
In large, yeah, I mean, we were talking about this with Anis this morning. Is like when do you know that you got a good answer, and compared to what if you have no baseline, and all of that, and yeah, I mean, if you don't have, I mean, most of these models, like you don't have data sets to even, and ground truth is. I mean, that's exactly what we were saying. Like, neither the data sets are there, nor the ground truth is, and you're just, and then even you train your model and deploy it, like say ChatGPT, and then it starts performing badly as time evolves because the data has changed. So, I mean, these are all moving targets, and you have to, again, I always go back to what is your end goal and what are you going to use this for, and then move backwards from there. So, yeah, okay, if you have a lot of data and you're going to train it until it fits it perfectly, fine, it's not going to generalize, you can backtrack, but most of the time you don't even have that luxury in real use cases, exactly as Anis was saying in the morning. So So yeah, I don't know if I answered your question, but I want always I always want context. I always like ask people, you want AI? Well, give me the context. Give me what you want that to do, what you want to do it for, and then we start with your data and what kind, if whether you're labeling it, whether someone else is, and are you training it yourself or are you bringing a trained model and then moving from there? Yeah, so that's where I always go back to, like exactly what you want to do, and let's see what you have and how we go from there.
I think that sets the ground for the presentation. So if you can go first on your slides.
You looked at my slides.
Yeah. Damien, can you share a slide? So I'm gonna give you this.
Am I gonna present
Yeah.
now? Oh, okay,
Yeah.
cool. All right, cool.
You can either,
This one? Let me see. Oh, cool. I'm just gonna check in. How do I? By the way, this is me, and I'm in Paris, and I'm here in Virginia, and I'm based at James Madison University. But do I?
yeah, I think Damien will help to.
You're gonna press for me?
All right.
Oh, okay.
Just tell me when you want to move slide.
Oh, okay. I'll tell you. I don't think this is gonna work. Oh, it's working now? Okay, sorry. All right. Speaking of use cases, so I work in AI, and I have 4 different ways I work in AI. And I think it's important for people to separate these layers because all of them need different skill sets, different strategies, different time investments, different money investments. So you want AI, all of you, but you want to know exactly which layer you belong in and what kind of stuff you need. So I'm gonna just mention them very fast. I'm gonna start from the bottom. It's like always in the bottom. There's always the real life use cases, like exactly what real life projects that affect your business and align with your mission. The most important thing for me here is that the project is implementable, and whatever we end up doing in real life does not go to wasteland, because for me time and money is the most important, and I've seen so many people work on so many things that go nowhere, and the way we do it here is we do it very different. And then part of the way I work in AI also is understanding the foundational models, which is all of them are in my book. But these models appear and die every day. Every day someone's doing something different, using a different function, using a different loss function, training different data sets. So they change a lot, but the principles are the same. So we focus on the principles, and I also focus on these models, standalone models, and how they integrate into systems pipelines, because these are also different. Do you apply this model to this one data set and do something with it, or are you integrating it into your whole pipeline, and how you use it? And then at the higher level than that is the interface of AI and data infrastructures, and at all levels of an institution or company. And then the very, very top level is the AI and data strategy at the institutional level. So if you look at this from bottom up, it's like the need that's driving the AI use. And if you look at it from top down, it is the strategy. It's a top level strategy, AI or data strategy that's pushed down at all levels of your institution. So these are not like fully isolated. They are separated, but are not like isolated, because knowledge of one informs the other. So they do inform each other. And the underlying principle is that that we have processes, and for some reason we're not happy with them. Most of the time we want improvement, and we want to automate our processes. So that's basically what drives progress at all of these levels. So at the very bottom level, the real life projects I work with, these are just consulting work. We get projects from all kinds of entities. Some of them are the military, some of them Department of State, some of them are fire department, transportation department. But usually what I've noticed that's common with all of these is they all come with very similar problem. They all have problem with their data, and they want to do more insights. They want to like upgrade some processes. What I've noticed that works, because we've delivered on all of these projects in very short amount of time. So as I said, implementable is so important. So one of the most advice I give people here is that to talk to stakeholders at all levels, talk to the people on the ground, talk to the Marines, but also talk to the Assistant Secretary of State. Talk to everybody in between and see whether what you're proposing is implementable, or if people are doing it already. And it's good to use existing technology and build on it, as opposed to just tell them destroy everything and do it all over again, because there's resource constraints. Expect to not have data available like Anis, and it's like it's what you said today was so common, and I see it all the time. Like, you have to sometimes work without data, and you have to innovate, and you still need solutions. There's red tapes of all kinds of things. There's some people, like, your solution is gonna threaten their entire department, so there's a lot of politics involved. So in real life projects, if you want to see them into delivery, you have to like follow this process. And then some bragging rights, just to give some credibility to what I do. These are our students presenting to Assistant Secretary of State and all of his, for Diplomatic Security Services, and all of his deputies and directors for 4 hours, and at the fire department. So all of this is super cool. I'm speaking at the GTAC conference. This is like the federal, federal government in the U.S., all the information technology chiefs and all of that. So it's really cool, but that's because like we do deliver eventually. And I'm also speaking at the UN General Assembly in the science. So in case you were wondering, we do deliver and we do have some value. But what I do notice is that usually there are 3 big continents driving AI, and there are the US and Europe and China, but there's the whole rest of the world. So we give courses in South America, for example, and there are other people all over the world. That's where your opportunities are. So do connect with these people and do find opportunities. Everybody wants AI. AI does have potential, but you have to like make the connections and see what exactly their use cases are. So my second level is the foundational models. So these are, as I said, standalone, and how they integrate into systems pipelines. So in what I did in this book, and what I always preach, is that all these models, like you were telling me this morning, that they seem different, but in general, they're doing 2 simple things. They're either deterministic models or probabilistic models. You're either learning a deterministic function in each one of them, or like linear regression, or nonlinear regression, or a neural network, or you're learning a probability distribution, and what your assumptions on these probability distributions are different from one model to the next, but it's all understandable. So if you kind of separate it into input, output, linear, nonlinear mapping, if you separate it in your head that way, you should be like very good and seeing it all from above. And then the next level is the interface of AI and data infrastructure and all levels at value of supply chain. This is the part where I didn't know anything about when I was writing my book, and I ended up spending a lot of time. I realized I had a gap in that. I didn't understand what happens before the stuff that I use, and I decided that that's the stuff that I needed to learn. So I'm basically with the right crowd here, so I feel like that's what you do. So I was here. So AI stands on all of this. It stands on data engineering, software engineering, the hardware that goes into you need all of this, and you need the models. So I was here and I wrote a book about AI, but then I spent the whole year trying to understand exactly what the rest is, because you really hit a wall in your knowledge. You cannot answer people and advise them on what's going wrong if you don't at least you don't have to be an expert with all of this, but you should have an idea of where things can go wrong. But AI doesn't only stand on these pillars, it also enhances them. So AI can help the material design for it. It can help, I mean, there is a feedback loop here. So all of this helps each other. So the more, and then one thing is, if you're doing AI coming, say, from any of these pillars, you run the risk of reinventing the wheel because you don't know that there are hard-learned principles and hard-learned lessons that others have already done. So you do want to know to collaborate with people who are have a specialty in this, because you don't want to redo their mistakes when you're trying to solve problems. So again, talk to people at all levels. And I noticed that most of the stuff is like you have input and you have stuff that happens to the input, and then you have output. For example, for data engineering pipelines, that's from you, Joe, it's a whole mess of data sources and then data engineering pipelines, and you have pretty data in the output ready for dashboards and analysis. Or you have a LinkedIn post, and then you have a machine learning model that classifies your LinkedIn post, and then you get a label, and that label triggers some action. So if you think of things as input and output, then a lot of things come together nicely, and you don't have to feel like you have to learn so many things you don't know. And then I noticed that a lot of people treat machine learning as this this separate entity that they don't know anything about, but in reality, it's just part of the pipeline. It's just a function. You change a function, input, output, and you kind of learn it. So I wouldn't treat machine learning as separate. It just succeeded recently, but it's just one more thing to learn that is not. Your machine learning engineers don't have to be separate than your other engineers, and they're speaking different language. There is a common language. That's my point. And then at the very top level in my triangle this is my favorite. It's the AI and data strategy at the institutional level. It's my favorite because I end up talking to the people at the top, and it's so good to talk to people who have the power to affect change. That's good for a change. And it does help me understand the institution. For example, this is our institution at the university, and we're trying to implement AI and data strategy at the whole institution. Just to help you understand our institution, we have 22,000 students, we have 1,400 faculty, 2,900 staff, and we have 139 programs, and we're trying to redo the whole ERP system, and we're trying at the same time to implement data democracy and data governance and AI strategy. So that is a huge project. I'm learning a lot in that project, but there's always moving parts. Institutions are not static. For example, as we were thinking about this, a whole division came up from here all the way to report to the president as opposed to report to the provost. So all of their reporting structure and data flow and authentication, all of that changes. So we have to have data models or whatever that accommodate those kinds of changes. But then this AI and data strategy at the institutional level gives me full loop back into math and explainable AI. So because part of when you're working at the institutional level, you have orders from the governor that you have to comply with. You have, for example, here you have your European Act. In Virginia, we implemented the governor implemented the first AI directive in all of the US, and I'm sure a lot of states will follow suit. So in that sense, we have to document everything. We have to also make our AI explainable. And then we have to think, what does explainable mean? And all of that. So in order to implement this strategy and make it compliant and with regulation and auditable, like yesterday with Benoit, we have to know what explainable AI means, and then that brings me back to math. And so if you think about AI, it's always representing high-dimensional data with lower-dimensional vectors. Like you have data of all types, and all you're doing is you're doing embedding vectors, and then you're doing decisions or calculations with these vectors. So how you move from data to vectors could be linear, easy to explain, or nonlinear, which is more math to explain. But in the end, you're not doing anything but that in any of AI models, right? So for example, convolutional networks for images, they move from images to a vector. and that is in a nonlinear fashion. The nonlinear fashion is the actual convolutional network, the function representing it. But then here is just a convolution operation moving from an image into something that you see the horizontal lines. That is a linear map. I can convince you later. But it isn't that much different, right? It's either linear or nonlinear. And if you understand that, you can explain a little. So in linear, you can always explain more about your models, how every input feature affects the output. But in nonlinear models, for example, then you have to like do more math. But that math is doable, and someone needs to sit down and do it. And that's my next steps. And so what are the essential components of explainable AI? That is what I'm working on right now. You have to understand the models, the data, the deployment use cases, and the limitation of each of these models. And then you have to understand the exact contribution of a point attribute to the embedding dimension if you want like your models to be explainable. And you have to understand the pipeline from the data to embedding to a decision. It's important to know if your AI is making decisions, you have to know how that pipeline worked. And you have to quantify and report uncertainty with the model's predictions. And you have to quantify causality and correctly model logical reasoning. So a lot of people only talk about correlation, but if you want your AI needs to reason and say, I made this decision because of that. And just observing the data is not enough. You need to do more mathematically. You need to quantify observing and make it different than intervention, and make it different than had I not done this, what would I have observed? So this is how humans reason, and this is, all of this can come together using explainable AI. That's what I'm working on next. So basically, my advice to you is dive into what interests you and has and brings value. You have to understand, like, you have to start with what is the value, what's the use case, and it actually gets you places, is implementable. And it's okay to question how people do things now and why have they been doing it this way. And if it's not working, just drop it and do something else. We do have an opportunity. I see a huge opportunity. First of all, there's a ton of investments. The entire governments are investing in this. Every single entity I talk to is doing this. So all of you have a lot of opportunity, but we have to do it like thoughtfully, and there's a lot of improvement. So this is the foundation, in my opinion, of AI and data. There's a hardware, there's modeling, communication, data, and there's at the top level the enterprise and data strategy. I can dive into all of these, and I can dive more into this if you want to ask me afterwards. And this is it. Thank you.
Any question in the public? Or from your side? A bunch of information. It did resonate a lot with my. So I come from a data science background, and when I was in studying this field, all I had to learn was how to apply, I don't know, SVMs or decision trees and so on. And it was really only when I went into industry that I realized that, okay, it's not all right. It's not only about modeling, and I had to do it like in MATLAB or R or something, and then I ran into real coding and real implementation and going to production and so on. And there's a whole gap to fill between academia and knowing the models, but doing it in a practical and implementable way. That is really the hard thing for me to bridge this gap.
And it is a hard thing for everybody, and that's why I make sure to highlight that. That's why I put all of this together. There is no curriculum and no department in academia is teaching it in an implementable way or bridging all of these gaps. Like, you learn, like you said, SVM, and you implement it in MATLAB. You have no idea how it fits in a production pipeline, or what it talks to to other models, or what you use it for, or whether there's other models who do better for these use cases. So this is why it's important to know the full stack of this, and also talk to the people who have experience implementing these and have done notice the pain points and overcome the pain points. So you don't have to like reinvent the wheel, but just so it's not only it's a gap in it's our fault, academics.
No,
Like our fault.
Just
that's
us.
your fault.
Okay, well, we'll blame for that.
Yeah, you just have to learn a whole bunch of things coming from a mathematical background and then going back to software engineering, data engineering, and so on. How did you learn it all if it's not by your academical background?
How do you learn it all? Or
I mean,
I don't
coming
know.
from a data science background and writing a book on data engineering and architecture and so on, it seems like a big gap to fill.
I don't know. I mean, I guess I'm one of the weird people who, if you ask me what I do on the weekends, ask me what I do on the weekends. Well, thanks for asking. I
You do the
like
weekends.
I like to spend my weekends nerding out, right? So I think it's always been about continuous learning and pushing yourself beyond your comfort zone, and I think embracing new areas. And I felt like data engineering is one of these areas where I did it out of necessity, because if I didn't set up the infrastructure, like I literally couldn't do my job. So
Yeah.
some data scientists, I think, would just they would choose to not do anything and maybe just go play Halo or something
Yeah.
all day, which is it's actually more fun. And I would say you should do that actually versus do your job. But yeah, I guess I'm the weird one who I've always, even on weekends, like I probably read like 20, 30 articles in the weekend related to data in the field. And that's just how it's always been, even since I would say even the late 90s. And so every weekend has just been like reading books, coding, pushing myself. So I always reserve like weekends for learning new stuff, and then the weekdays for implementing those things. And so I always felt like data engineering was just a natural progression of things from things I had done before.
Mhm.
And mind you, I got into it before because it was called data engineering, but I just felt like that was me having to do my job. So, because there's this old trope, like data scientists spend 80-90% of their time cleaning data,
Yeah.
gathering data, smelling data, fondling it, whatever they do. And so, and not much time actually doing stuff with it. So I felt like the role of data engineering is really to do that 80-90% of that stuff. So data scientists could spend 80-90% of their time doing the things they were actually trained to do, which they unfortunately don't get to do. So, yeah, I don't know. But I've always been curious, about like why things are the way they are, and like why do things suck, and why can't we make them better? And so that's, to answer your question, I suppose that's how I've been able to, I guess, cross those gaps. It's just because I'm not ever happy with anything. So
Yeah, but I do understand. I learned that lessons the hard way. I was working with other data engineers back then, and they all looked at my crappy code in my notebook, and they said it's just impossible to
yeah,
work
you
with
should
you
find a
guys.
different career
So-
field. Like,
So I had to
Do
learn.
something else. Don't write code.
You're not a developer. You're not a
Yeah.
coder. Okay. I'll try
yeah.
my best. Speaking about weird things to learn, how did you fall in love with data catalogs? Ole? It's hard
Or
to
like, why
understand.
did you?
I-
fall
Why?
of anything in this world,
Why
you fall in love with?
Save
Like, why
us.
that?
I never loved data catalogs. I don't love data catalogs.
Do they love you?
No, they hate me.
Okay.
It's
We
a
hate each
toxic
other.
relationship.
Yeah, it's complicated. No, no, I think it's the other way around for me, right? So I have a knowledge, as Joe alluded to earlier. I was trained in this discipline that is very, very niche. And then what happened while I studied was that this discipline, library information science, it became irrelevant, because basically I was studying while the web was not something that like only young people used, or like people used to just do experimental stuff, but it was literally invading our societies in the late 90s and the early 2000s, right? And so I was studying this discipline that had two dimensions: a linguistic dimension, understanding language, understanding literature and the history of language and literature. And then the other part of that discipline was technology, really understanding databases, information retrieval query languages, understanding search techniques and behaviors, and cataloging. And cataloging in the sense that it was deeply marinated into computer science and like the entire development of the MARC format, the machine readable cataloging format in the US that kind of built this, that literally not only electrified but digitized our literary heritage in the world. That discipline, a majestic discipline, completely evaporated those years. It disappeared. There is only a handful of people working with these technologies and ideas. But then there was this new discipline inside this discipline that became known as information architecture. A lot of people saying, okay, the web is emerging, but maybe that's not a bad thing. Maybe that's not something that takes away our monopoly of providing access to information and data. Maybe it's something where we can play a part. And that school of thought was kind of a train that left the station, and there were people on the station saying, I want to do librarianship and I want to do what I was trained to do. And then there were other people, like authors like Peter Morville and Louis Rosenfeld, great authors, O'Reilly authors of a generation prior to mine. And they said, nah, I'm going to take that train. And so they defined information architecture. They said, if you want to build functional information architecture for the web so that web pages work, so that search engines work, all that, then this is what you got to do. RDF, very good. Let's help with actually implementing that. Let's refine that with the data community. So they did that. And luckily for me, totally by coincidence, I took that train, Johan, as a student. Mm-hmm. And I said, okay, that is where this discipline is going. It wasn't what I thought, but it's that way it's going. Mm-hmm. And then I worked in technology. I worked as an enterprise architect for many years. And then I was confronted with this beast that someone told me to implement, and they called it a data catalog. And I said, okay, let's look at that. And frankly, to be honest, I was so disappointed when I saw a data catalog the first time. A horrible technology, clearly not scoped as a functional catalog that is destined for perfect way of organizing and searching your data. So that kind of revived the academic in me, and I said, I have something to say about this technology category, and that is why I proposed the book to O'Reilly. It was actually because I thought that many of the tech vendors out there, they did not know what a data catalog was about at all, to be honest. They could define it from a computer scientific point of view. They could build it, no doubt, but they had, I'm sorry to say, not a lot of understanding of how the end users would behave and how it would actually be beneficial to companies. Mm-hmm. And so that's what I write. I'm getting a little heated up, but I'm more polite in my book. But it's actually why I wrote the book, and it is also you can find the passages where I mentioned this in my book. I was like, we gotta look at this technology category from a completely different angle if we gotta make it work.
I was willing to ask you, how do you present your book in 3 sentences? But I guess you did the work. You want to react? Sing the mic.
Well, no, but I who was it? Our mutual friend Jessica Talisman. She turned me onto a book which I am reading right now, The Accidental Taxonomist, and I think it's a great book. Mm-hmm. It's a riveting book on taxonomies. If you really wanted to make your sex life amazing, read this book. I mean, look at me. So it's a great book. Taxonomies is all you need to know.
Just that is the best. But I think that even that, I won't go to that extent, but understanding the depth of text.
Well, come on, man. I mean,
yeah, okay.
you were booking data cataloging.
Yeah,
I mean,
yeah,
it's like, I imagine things are going great for you.
Thank you. Yeah, I'm doing all I can.
Yeah.
But losing it. Apologies.
I'm a bit jet lagged right now, so this is what happens.
Yeah. Don't worry. I think there's so many things that we can learn from this very old, weird discipline of library information science
I agree.
in the data community, and I'm happy to be one of the voices. I'm not the first. There is a small group of O'Reilly authors in the generation before me that wrote excellent books on this topic. Ambient findability, that's my definition of data democracy. I didn't invent search anything from anywhere at any time, and anyone should be able to do that. That was defined by Peter Morville in ambient findability.
What year was that?
2005.
Yeah.
So he was reflecting back on the emergence of extremely powerful search engines, right? And he was thinking, okay, what is this? What is the, back then we talked about it as the Googleization of everything, right? That we could search and find anything from anywhere at any time. And that completely turned society around. Now, if you want something, anyway, maybe I should say, this is some of the things that I wanted to say during my talk, but I can...
This is going to be your time. You can start.
Yeah, I think it will be a little more dynamic. I only have one slide, so it's not as smooth as Hala's. Should I go ahead and say that?
Sure.
Is that okay with you, Joe?
You were. I don't care.
Do your slide. He wants to do his.
But
demo.
You should do your slide. You should do. I don't even have slides. At least you have slides.
I
You
feel
said you had one though. You have
overprepared.
like a bunch of them.
You
yeah, I
guys
have, these
tricked
are all the diagrams from my book. So,
me. You two tricked me. You made me prepare. You didn't tell me you weren't having slides.
yeah, we were just kidding around. But
You were kidding.
No. Okay, so, but I guess I told who I am, right? So I'll just use the slide as a background of saying something more. So continuing on this train of thought in terms of ambient findability and Peter Morville, the older generation, I dare call them now, of O'Reilly authors from library information science. I think we are witnessing, so some of the things that I wanted to say, I have said, so I may not use the entire 10 minutes, Johan, but I think we are in a very interesting point in time in terms of search. I always think we are at a very interesting point of time in search, but what happened on February 9th, 2023 was something very spectacular when Satya Nadella, he declared on stage that it's a new day in search. Microsoft announced a partnership with OpenAI, and they wanted to take market shares. In doing that, they wanted to take market shares from Google, saying, we have a new and more powerful way to search the web. And it's a combination of classical search engine mechanics and chatbots, LLM-powered chatbots. And it was a big claim. It got on the cover of The Economist as the battle of the bots. And everyone was thinking 1 year ago, it's not more than 1 year ago, everyone was thinking how we search the web is going to change dramatically, and it's going to be improved, and it will happen on the basis of large language models mediated through a chatbot. And I was eating popcorn, watching that press release, because I think, so there are 2 points to this, and I want to get back to both points, because I want to talk a little bit about Sinea and our vision. But the first point is that Satya Nadella's vision, you can be a fan of Microsoft or not, but that didn't happen. That didn't happen at all. Microsoft is not taking market shares from Google in traditional search. So that didn't happen at all. But something else happened. And I have 2 podcasts that I listen to to really understand that it's the Decoder podcast by Nilay Patel, and it's your podcast, Joe, because you also
Oh, which
discuss it a
one?
lot. Well, it's the Monday Morning Data Chat. I
Oh,
tend to
yeah.
listen to that. And it's the fact that something close to the opposite is happening to the web. The web is becoming a mess. It's becoming flooded by AI-generated content that distorts search to a very large extent. It's becoming more and more difficult to find good sources on the web, which is a big paradox, right? We thought it would be a force of good, something that would push us forward, and that may be the case. But right now, we are seeing a lot of tendencies going in the completely different direction. That, I think, is a big, big paradox. And so, back to Senea and what we are working on, because there is this parallel between data catalogs and search engines for the web, meaning that data catalogs ideally should work as search engines. And I think with the movement that we are providing in Senea, our vision in Senea is like pushing towards an enterprise data marketplace, meaning that we're trying to make data as consumable as products. Now that pushed search engine mechanics forward for the web for several decades, right? The fact that the web got so efficient and so efficient by search engines is rooted in the very fact that people want to sell stuff. So if they want to sell stuff, they want to structure their data so efficiently that a search engine can find it easily so that people can sell. That's a simple logic and it works. It's markup, it's basic markup language, right? Now, that logic is getting distorted right now on the web, but it's paradoxically enough something that is emerging for data catalog with the advent of data mesh, the idea of data as a product, not as an asset, but as a product, as something that you can actually make consumable. So we may be in a situation where data catalogs will finally work, we hope, with the movement towards data marketplaces, data products, and data providers, data consumers.
Do you think the term data catalog should go away though? Because I feel like there's a lot of baggage that goes with it.
Yeah. I agree. I think the data community have trying to kill the data catalog term for many years with many variants, right? But it's just like there's nothing.
What would you replace it with, though?
Yeah, exactly.
Search engine?
People have called it all kinds of things, like the active metadata platform.
That's
and
terrible.
Yeah, that's pretty
Like,
horrible.
that really sucks.
Yeah. So I don't think it will be replaced, but I think we will agree that data catalogs will have a layer or a dimension or whatever that will be an experience plane, as it's called in the mesh, in data mesh theory, or an enterprise data marketplace, as we call it, or data marketplace.
I think I got in trouble last year when I spoke at the One Point conference last year because somebody asked my opinions on data catalogs, and the worst thing you can do is ask for my opinion on anything because I don't really have a filter. And I said that I think they're pretty terrible. So, yeah. But I think that for the reason that nobody uses them, you implement them and it's like, that was cool. It could have saved you the extra step of just not implementing it because it won't get used. So it's the same thing, you know what I mean? The thing is, for the longest time though, it's been. I think people have this grand vision, like, oh, let's make a repository of all of our knowledge in our business and make it searchable. And like, for the end user though, can somebody? I have a friend who's waiting out front here. Can somebody go let him in?
Oh, it's
Sorry.
Demetrius?
Yeah, thank you.
Yeah.
See, I can multitask.
Live.
I think we'll save some of that debate for tomorrow, but sure. I mean, I don't. I'm not very like discreet about the fact that I think data catalogs have had, in many cases, a problem with justifying their existence and especially their cost.
Yeah.
I see them work. We have happy customers, so they do work, but they have to be crafted in a very specific way to actually work.
Yeah, like I always think of it like dental floss or something. Like people say you should do it. Like you should do like really hygienic things for yourself. And then how many people actually do that, right? Like you should actually. It's kind of
Even
gross if you
though
don't floss your teeth, but
I think I think mimicking a commercial structure will work better than what has worked for many companies in the past.
yeah. I
Can
hope
you
so.
just say like that a search engine and like just that, would that like replace the whole having to say data catalog or whatever is underlying that?
Yeah.
Can you just say that data search engine? Everybody wants that.
You need a search engine.
Yeah.
Yeah, I just said it.
Yeah. See, instead of like what's underlying it and what's feeding it and all of that that can be hidden below.
It was actually a big concern for me writing the book, right? That the data catalog, the term is so horrible that I thought, it may affect the sales of my book because just the term of it, it's just so horrible.
Well, I thought that when I first saw the title of your book, I was like, oh, he's going there, huh? All right.
Exactly.
Well,
But am
Oh,
I
well.
missing something to just say search engine and hide the technology that's under it beneath that? Am I missing something that I don't know?
Depends on how
Does it
deep you
have
want
to
to
be
go,
a
right?
catalog?
No, I think the basic difference between a search engine and a data catalog, unfortunately, I don't think you're missing anything, Hala. But I think the basic difference is that a search engine, and I also want to do a controversial statement. So I think building search engines is easy, right? Because you have one source, and it's the web, and the web is like,
But for data.
yeah.
That's what I mean.
So when you do it for data in a company, you have like hundreds of
Correct.
thousands of sources. They are all different.
Correct.
They are all very complex, and they are poorly maintained because they are not intended for consumption. So, but that's going into the weeds. Basically, it should work like a search engine. Yeah, it should
Yeah.
be a knowledge graph. It should be
Exactly.
simple for the end user. It should be super smooth and not complicated, and like all the mechanics should hide behind
Behind
the
it.
user interface.
That's how I would want it.
Speaking
Yeah.
of search engine, so I will take the end this question that he told me. So he told, at the end of the day, a data catalog is just a search engine. Do you think today data catalogs are like Yahoo, willing to organize the web,
how are you?
or new data platform willing to leverage its Google counterpart, where everything is dumped in the search big algorithm?
Yeah, I think I have to get them. Is it Andy Petrella's
Yeah.
questions? So yeah, I think I answered it.
Do you think today data catalogs are like Yahoo, willing to organize the web, and new data platforms will leverage its Google counterpart, where everything is dumped in a search big algorithm?
Yeah, so there are several. I managed to read the question before, and there are several elements in the question that I do not like, Andy. So we have to meet
Andy.
in person, Andy, if you're still following the presentation online. But I basically said my point. I think we are in a very paradoxical situation where the web may, for the first time, become more difficult to search due to the rise of so much crappy AI-powered content, then it may be more difficult to search than internal IT landscapes and companies using data catalogs as data search engines. So that's a big paradox. So I'm not saying it will turn into search engines, because I don't know what search engines is turning into right now.
It's true.
Yeah. So I think I need to leave some time for.
Well, they're turning into answer engines. There's no search. Like back in the day,
Yeah,
you were provided with multiple search results, millions upon millions, and now it's a single answer. And that's what I meant by the overfitting question earlier. It's kind of like how the moment that you're not accurate, people lose believability in the answer, right? So you need to be like 100% accurate, but then what does that look like? Especially when you have things like what happened with Gemini, where you have results that I think some people were a bit peeved about. So is that the answer that you get? And I don't know. So I guess it literally is the answer that you get.
Yeah, it's an answer machine, right? So I love the term answer machine, and I totally embrace it. I just think that, and we can even explain it mathematically, that it's two different things, right? You want to have one super precise hit, the answer.
And I wouldn't want that.
I tend to not want to
I
have
wanted like arrange with certainties about each of those.
Yeah.
Like that's why quantifying certain uncertainty comes into play, explain all that stuff.
I think we should. Yeah.
Yeah.
Anyway, I'm taking all the time here.
No, that's
But-
right. I move on to you, Joe. You have 3 sentences to convince people to buy your book.
Well, 3 words, buy my book.
Sentences.
Yeah, the book's amazing. It'll make your life better. Go buy it. There you go.
I wasn't expecting that, but okay. You do mention in your book that like modern data stack isn't so modern.
Yeah, I wrote that back a few years ago before everyone said it was dead.
Yeah.
So there. Yeah, what was your question?
Yeah. So can you elaborate on why is it not so modern?
Well, who's familiar with the modern data stack? I know Christoph. Christoph's written articles on it too about how it's awesome, and I still think it's cool. But I felt like it was a point in time, and this will kind of get into a few other things in a second. So the modern data stack, right? I placed the data vits beginnings in November 2012 at reInvent when AWS Redshift came on the scene, and you could rent a cloud data warehouse for 25 cents per hour, the starting price at least. Pretty dope. Before then, did anyone try and get data warehouses before 2012 or November 2012, and haggling with vendors about buying the box and then installing that box on your on-prem server, and then doing all kinds of fantastic things with the box? Like, I don't think anyone wants to go back to that world. If you do, let me know. I can introduce you to some great vendors who will, sell you that for a lot of money. So, but what the whole model meant is you had a consumable cloud first plug and play ecosystem, right? So subsequently you had tools like Fivetran and other tools that came about that really took advantage of another movement that happened at the time, which was SaaS software as a service, right? So all these things came into play. I was going to use the word confluence, but that's a pun on Confluent, which we'll talk about in a second. And so the modern data stack, I think really what the benefit of it really was is that it brought about the ability to do analytics at scale in the cloud for cheap, right? In a modular plug and play fashion. I don't think anyone would disagree that that's net an awesome thing, right? I mean, what it meant is like anyone in this room can spin up and do analytics on gigantic data sets, complicated data sets, in a pretty affordable fashion, right? And you can tear it down, spin it up, whatever you want to do. I don't give a shit. So that was what happened. And then, who's seen Matt Turk's Mad Data Landscapes slides with like the billion logos of all the different open source and startups and players in each ecosystem? So what happened was you started getting like hyper verticalized in every niche in the modern data stack. So suddenly you had like observability and then variants of different observability and then niches upon niches, right? To the point where, and a lot of this was driven obviously, by the popularity of the modern data stack. Snowflake IPO attracted a lot of interest and investment in the data space. So all of a sudden it's like, well, crap, I mean, let's be that next Snowflake, IPO. And so you saw a mad rush of companies into the data space, and then COVID hits, and interest rates drop to zero, and all hell breaks loose, right? Pretty soon, Matt Turk's slide. I remember looking at his first 2012 slide actually when it was still the big data landscape, and I thought that was confusing at the time. Notice that there's probably, I think there may be a handful of those companies are still around. Like Cloudera was one of the logos on that, and they're still around. But a lot of absorption, a lot of things happen and consolidation and so forth. And that, you're starting to see that right now with the modern data stack, right? So what my comment 2 years ago when I wrote modern data stack isn't so modern anymore is I think the goals of the modern data stack, that achieved its purpose. That's where the modern data stack succeeded, right? Like democratizing the access to very powerful analytics tools. So it solved the classical data warehousing analytics problems out there, right? But as we pointed out, and then subsequently, Tristan Handy from DBT wrote recently saying the modern data stack is not a useful term anymore, and I completely agree with that. I think it's time to move on. In his way, it just, now we're back to doing analytics, which is the whole point anyway, right? Because anytime you put the word modern on something, you can pretty much guarantee the the timer starts on that, and then it's not modern anymore, and then you're got to find something else that's modern. People joke it's postmodern, but that also means, like, if you studied postmodernism in the 20s, it was like that's an era of nonsense, which I can actually say we're in right now. So maybe that's a different discussion. So yeah, it didn't feel modern anymore, just because I think that, again, it accomplished a lot of its goals, and it just became sort of a meme unto itself, as Tristan pointed out. And so, you know, in the final chapter of our book, we actually called out something that is happening right now, actually. Who's paying attention to what Confluent was announcing this week? Right? Kafka Summit. So a lot of cool stuff. We called this out in the last chapter of our book, looking at the future of data engineering. And one of the macro trends really is you're going to see, in the same way you saw classical analytics being solved in the cloud in a composable, cheap, modular plug-and-play way, the same thing's going to happen with streaming data, right? That's the next shoe to drop. And so you're already seeing this. We called it the live data stack because we just like puns, I guess. But something like that is emerging right now, where the capabilities of doing streaming real time is going to become so simplified that you'll look at doing batch data as basically the equivalent of like a dial-up modem. And so there are certain use cases for batch. I think that it still has its place, but if you could do things in real time, then why would you ever go and do things, on a batch basis? You know, I was talking about this with actually Toby Mao over at SQL Mesh, and he's got a good point. Maybe if you're doing experimentation, batch still has a good play because it's just way harder to do statistical experiments in real time, but that'll probably be solved too. But so the whole point is like, what happened at they Flink's a first-class citizen now, and then their ecosystem, right? And they introduced something called Tableflow, which I need to dig more into. But like, all this stuff is going to become extremely simple to use, right? So all this plug-and-play architecture that you saw with modern data stack, that whole thing's going to do the same thing in streaming. What that means is just either the ability to get faster insights and automations through machine learning, or the ability to do dumb things more quickly. But the thing is, unlike batch, real-time streaming really, it's a forcing function in that it brings all the disparate parts of the data sort of life cycle or engineering flow together in a tighter feedback loop. So actually it means that you're able to solve problems much more quickly, i.e. bugs as well, because you have better feedback on them. If things are in batch, it's like, I don't really care what that happened, didn't notice it. So the live data stack also means that the feedback loops between software engineering, data, machine learning becomes so intertwined that there is no difference at the end of the day. It's all the same thing. So all these artificial divides that we have, which I think are actually inhibiting us from creating, data products in the sense that Zhamak described them, this sort of goes away when all these feedback loops converge, and all these, I think, artificial walls are broken down, right? So her vision really was, with the data mesh, was at and I had to argue this last year, and it's kind of funny, but data mesh will be the death of data engineering. I wrote the book on data engineering, but I had to take the side that it does actually. So that was kind of funny. So I talked to her, get the cheat notes, and really I think she's absolutely right at the end of the day. Right now, we have all these divides because we lived in this world where for the longest time IT was an internal facing IT function. Right, you're providing internal reports. That was great in the 80s, when Bill Inman came up with the data warehouse, right? Because that was to free data from the constraints of querying, from carpet bombing your OLTP database with analytical queries and bogging that down, which is what would happen. So he had this notion of, what if you just had a separate place where you could carpet bomb that with queries? And that became the data warehouse as it exists to this day, right? Subject-oriented, non-volatile, time invariant, data store for the purpose of management decision making, to paraphrase the true definition of a data warehouse. But the same thing now. Now you're dealing with products that are external facing, customer facing, right? It's no longer a world of internal reports and TPS reports and all that stuff. And so that's where I think everything's going. So to answer your question, yeah, the modern data stack, it's no longer modern. I don't think it's no longer useful. It fulfilled its purpose, and it won at the end of the day. I think that's the whole point. It didn't fail.
Yeah,
It won spectacularly. I don't think anyone's going back to the old days and saying, let's go back to 2010, and I'm going to go get, a 3-year commit contract from a giant vendor who's going to, beat the crap out of me with lawyers and everything else. I don't think anyone wants that. So it won. It did its thing, but it's time to move on.
It's true. Speaking of, and this really will be one of my last questions because we are running out of time. Speaking of something that don't feel modern anymore, but you are really reliving it, is data modeling. When I entered the field of data science, I had this feeling that everybody that was doing data modeling things were like all people that had to embrace data science.
Yeah.
And if they didn't, they would die and do other stuff. And now that we are trying to ship any kind of crappy AI and it doesn't work, we do understand that we need real data modeling and that we don't really know how it works really inside. And so I think that's one of your next topics.
Well, it's the next book I'm working on is data modeling. I mean, you want to talk about a really sexy topic that's just
I know.
steamy. But I mean, it reminds me of what Ole was saying about, library science is sort of going the way of Latin or lost civilization. And now you're hacking through the jungle and you come across like what is that? Is that a building? And you're like, oh crap, this was a whole city at one point. And that's actually what happened at Angkor Wat in Cambodia. They found that Angkor Wat was like a city of like 1 million people at one point, right? But it was like lost in the jungle for centuries. And that's sort of what library sciences were, and that's sort of what data modeling has become. It's this lost art form that unfortunately I think holds a lot of the keys to making us successful with data, getting more value with data, to use a lot of common tropes. But why is that? Well, I could say that the other thing with the modern data stack was it became really easy to do things. It became really easy to do dumb things more quickly, right? So when you can separate compute and storage, for example, this allows you to sort of cheat and just say, oh, well, I can just throw more compute at my query and have that run, and that'll solve all my problems. Never mind the fact that your underlying data set is an incoherent mess. It doesn't represent the reality of your business. I'll give you another example real quick. Like, throughout the 2010s and 2020s, there's a notion, who's heard of one big table? Like, just throw all of your data into one big table. That's literally what it is. And the whole notion behind that was, well, joins are not performant in column-oriented database. So let's eschew any modeling and just throw everything into one big table. I think at a recent talk I called it WTF, like wide, tall, and full. Same thing. So, but I think what you're starting to realize, especially now that is a pendulum, right? You go from kind of fast and relaxed to rigorous and formal, right? And we're going back to rigorous and formal because I think people are realizing the consequences of not modeling your data and not understanding what you've done to yourself, basically. So the book I'm working on right now, it's under the moniker of practical data modeling, but it's the underlying notion is this thing called what I call mixed model arts. So who follows mixed martial arts? So the notion back in the day when UFC started was, what would happen if you had a boxer versus a jiu-jitsu guy, right? Jiu-jitsu ended up winning because it was also a Gracie jiu-jitsu infomercial, the first UFC. But quickly what happened was you realize martial arts is really the combination of a bunch of styles in reality. If you're a boxer and you go against an MMA person in an MMA match, you're going to get absolutely destroyed, right? But this is how I feel data modeling is becoming something where you need to be cognizant of all the different techniques up and down use cases, right? Whether that's applications in software, analytics, machine learning. Because what's happening, again, we talked about data products. And you see this with DevOps too. It's the responsibility of a practitioner and someone who touches data to be cognizant of the different techniques of how to model data. So it's not just one technique, it's a bunch, because you're going to be expected to know all these things and when to apply them to that situation. Good ones and bad ones, quote unquote. right? So that's why I think it's coming back, because it's not a necessity. There's too many ways to handle data now, and I think the biggest sin that we've had as an industry is we assume that there's one true way. I'm not going to name any cults in data modeling, but they do exist, and I think that they're quite dangerous.
Yeah.
So I'll end on that note. Don't join cults, or join my cult.
Yeah. Not the others.
It's cool. Yeah, not the others. They suck. They're not the true path to salvation.
Right, I can get that. So we are approaching the end. I just wanted to conclude with some really light thing and on your book. So yeah. So I just wanted to give you some advice of how to market a book, and we'll take lessons from Hala. So here is how Hala is marketing her book. Just take really nice pictures and just I don't know if it increased sales, but
It
so
does.
it does.
immediately.
Okay. And here is how Joe and Ole are marketing their books. So and this way also. So
Love it.
these are all photos on
This
LinkedIn.
is awesome.
So I'm sorry guys, but
It's
you have to
really
take
awesome.
some lessons from
I
Hala.
think we can do better. Yeah, I
So,
get the point. I get the
Yeah, so I thought I would give you a little help. So this is your next picture. And I will conclude that. But I really thank you guys for this talk.
I'm wearing the
And
same shirt. That's funny.
but that was
I am too.
your LinkedIn post on the book
Yeah.
publishing.
Oh, Iron
First
Maiden.
one.
So on this very
That's really
difficult conclusion, I will really thank you all for gathering tonight
Thank you.
and
Oh,
really
thank you.
Thanks,
Thank
everybody.
you for being
It was
patient.
an honor for
That's
me.
awesome.
So for anyone who is on the live, we will now drink beers in person. So you can drink beer live, but sorry for that. Thank you, everybody. Bye.